Hey, Rachel. How are you?
Hi, I'm good. How are you?
Good. Have you
Good.
been on there long?
No, just for like 2 minutes.
Oh, okay. All right. I was sitting here working out some of the problems myself, so just reworking them as I wait. So, do you have specific questions, or do you want me to just go through the review?
I have one question only, and I'm trying to find it. Hold on one second.
Okay.
Um, I think it was number 36 was my question.
Okay. Let me. All right. This is one where if I could definitely work it there, but it might be bunched up. And I don't know. Do you want me to just go to a blank piece of paper and start from scratch so it looks prettier?
Yeah, that sounds good.
Okay. That way I think it'll be clearer than me trying to scrunch it up and fit it right there.
Okay.
One question before I get ready to start this. Would you mind looking at number 28 for me?
Sure.
Where you have to find all the rational zeros and one is given?
Right. Yeah, I see that one.
Okay. And we worked it out where we used the synthetic division. I don't know if we did it in class, but you use the synthetic division to find the first one, and then that helps you get down to the next.
Yeah, I remember how to do that one.
Okay. Do you remember how to graph it to find it as well?
No, I don't. Do we need to know how to do that?
Well, the one on the exam is not my favorite, and I thought I had caught all of them. And it actually, one of the other zeros is actually, you know how you get the potential zeros by doing P over Q?
Yeah, that's what I was doing.
Okay. And then that way you get there. Well, unfortunately, and I thought I had just examined all of them because I really wanted it to be like this one, because to me, this is the most important thing to get out of here, is to be able to do a synthetic one. And so I'm just vacillating as to whether I should just leave the exam as is, or tomorrow go in and say, here's the replacement, and do an easier one, because the one on the exam, to me, the best way to do that one is not use synthetic division, but use the graph. And all you do on that is literally graph it the way it is and then see where it crosses the x-axis, and those are your zeros.
So then there would only be 2 zeros.
On the one for the exam, yeah.
Okay.
But this one, obviously, there were 4. But I'm just kind of praying about what to do on that. And if you were confused on how to do it, that just means everybody would be. So that kind of helps me make my decision, because I've really been praying, because we caught it working through all of them. Like I had just kind of worked through them kind of in my head as I was walking through, and then sitting down at paper, we noticed it on Monday, I think, at the end of the day. So I was kind of bummed.
Oh, okay. Yeah, I actually had to look up like how to do it because I forgot. But then once I like looked it up and knew the method, then I could do it.
Okay. But back to 36, where your original question was. But thank you.
Oh, you're welcome.
Okay, so we've got the fifth root of the opposite of x plus 1 all over 2. And we're asked to find the inverse of this. So the very first step for me is I always change the h of x to a y. And then I have the fifth root of the opposite of x plus 1. And I think I talked about this. These are my confidence building steps in class, just because sometimes just figuring out where to start is half the battle on inverses. And then I'm going to swap places with my x and y, because that's really the definition of an inverse. is the fact that the coordinates on the coordinate plane, or the ordered pair on the coordinate plane, are just opposite of each other, and that's why an inverse is what it is. And so now I'm kind of ready to start now that I've swapped places. And the first thing you want to do to get rid of a fifth root, because technically I could rewrite this whole thing raised to the 1/5. So what I really want to do is raise this to the 5th power, because that's how I would get it out of the 5th root. So if I raise this side to the 5th power, I have to raise this side to the 5th power. So now I have x to the 5th equals the opposite of y plus 1 all over 2.
Okay. So now
And now,
multiply both sides by 2.
yes, good job. And now we'll subtract 1 from both sides. And now I have to multiply everything by a -1 or divide by a -1, however you want to think about it. So that changes my sign. So now I'm just going to rewrite that as h, the inverse of h of x equals, and then so I can lead with a positive, I'm going to bring my 1 out front, minus 2x to the 5th.
Okay, that makes sense. Thank you. I don't know.
You're welcome.
It was kind of easy.
Yeah, it's whenever when you look at number 36, it looks daunting and kind of ugly, but once you get rid of the radical, it's not too bad.
Yeah. And then one more question. Number 38, I was just looking through the packet to make sure. How would I get, once I subtract 8 from both sides, how would I get that 8 out of the denominator?
You would square both sides.
Okay, so
and then multiply both sides by 8.
Okay, so you'd have 10 equals the square root of x divided by 8. So so from there you would square both sides?
Yes, ma'am. I can do it real quick.
I think I can understand. So then you'd have 100 equals x divided by 8. And then multiply both sides by 8. Okay.
Yes. Yes. That's it exactly. You did it all in your head.
Yeah. All right.
Impressive.
All right. Thank you.
No problem. Have a great afternoon, and we'll see you tomorrow.
Okay. You too. Bye.
Bye. Hey, Braden. Hey, Matthew.
Hey, Miss Parks.
How are you?
I'm doing all right. How about you?
Pretty good.
That's good.
Did you have a specific question, or you just want me to start from the beginning?
I don't really have any specific questions. If Matthew does, we can go ahead and go.
Matthew, do you have some? Did y'all get a chance to see me do the ones I had for Rachel?
I just saw one of them.
Okay. Did you see 36? I did 36 and 38, and then we talked about number 28 because it's going to be different. I'm sorry, love.
I just saw 38, and that's it.
Oh, okay. All right. Well, I also did 36. So, Matthew, do you have a specific question?
Number 16.
Number 16. Okay. Good one to ask about. Rationalizing the denominator. So what you're going to want to do on this one first is you want to go ahead and factor that 50 in the bottom to get it a little smaller. And this is how you're going to do that. So we're going to have 5 times root 6, and then 2. And then what you're looking for anytime they're in a radical is you're looking for perfect squares. So 25, which is a perfect square, times 2 is 50. So now I'll have 5 root 6. And then I'm going to take that 25 out of the radical by taking the square root of it, which is 5. And then 5 times 2 is 10 root 2, because that 2 gets left in there. Okay? So you took all the perfect squares out, and so now I have root 2. Now to rationalize the denominator, which was the original question, you only have to multiply the top and the bottom by the denominator, or by the radical. And what is inside the radical? Just that root 2. Yeah. You don't have to multiply by this 10. Does that make sense to you?
Yes.
Okay. So now at the top, I have 5 times 12, root 12. And then that 2 is going to come out. That was our whole purpose in multiplying by root 2, was to get that 2 out. And 2 times 10 is 20. So, but I'm not simplified yet because my 12 has a perfect square in it. It's 5 times 4 times 3, because 4 is a perfect square over 20. And the square root of 4 is 2, and 2 times 5 is 10 root 3 all over 20. And now I know I can simplify that 10 and that 20. 10 goes into 10 one time, and 10 goes into 20 two times. So I end with root 3 over 2.
Okay.
Did that help, or clear as mud?
Yeah, that helped.
Okay, great. Okay. What other one? How about,
let's see.
Numbers 13 and 14, you had to do some of those where you had to factor inside the radical. How are you all doing with that?
I got those. Those are pretty easy.
Okay. You want me to do?
Do you want to do both of them?
Yeah, absolutely.
Sorry.
No, you're fine. This is what Math Lab's about. And Matthew, while I'm doing these, if you're good with those, you be looking for some of your other questions.
Okay.
Unless you want to watch, obviously. 2, you know what, Braden? If you don't care, I'm going to try and do it up here where there's more white space.
Oh, I don't care. It's all good.
Okay. I don't want it to confuse you. Like I'm writing next to 12, but I'm doing 13.
No, that's not confusing. It's all good.
Okay. So 2 times root 2 minus 3 times root 6. And the big one that I'm talking about, I've got this 24. And so what I want to think of when it's in a radical like that, and this is a square root because there's nothing inside the check mark. So I want to look for perfect squares. So I'm thinking of the factors of 24, like 12 and 2. Well, 12 isn't a perfect square. We got 8 and 3. Well, 8 and 3 isn't a perfect square. 4 and 6. 4 is a perfect square.
Yeah.
So what I want to do is factor that 24 into that perfect square. Does that make sense?
Yes, ma'am.
2 minus 3. So now I'm going to take that perfect square out by taking the square root of 4. So that's going to be 2 root 6. And now on a combined like terms, this is a like term and this is a like term. As long as it has the same radical, you can combine like terms. Yeah. So I technically have a -3 and a -2. So that's going to be -5 root 6.
And that's your answer? Yeah.
Oh, yes, sir. I can't go any further than that.
Let me try number 14 by myself.
Okay, cool.
Hmm.
Perfect. Love it.
Are you multiplying? No, you're okay. You're adding them on.
No, you're actually technically it looks like well you're combining things, but you don't have to do anything with that first term because it's in lowest terms. But that 27 has a perfect square in it. If you factor it, what would that perfect square be?
9.
Correct. So if you took the square root of 9, that's what?
3.
Okay. And then you multiply that 3 times that 3. So if you were asking about a multiplication question, once you take something out, if there's this is almost like a coefficient, if you will, this 3 right here. So once you take the 3 out of that, you would have to multiply. So that would become 9 root 3, as would this. Nice that they gave you the same number, isn't it?
Yeah. Oh, that makes more sense now. Okay, I did it a different
So
way.
now
I was getting confused.
Okay, so now you're just combining the -9 and the -9.
Which I do have a question. Do you think I could apply this if I did if I got to the point where it was 2 root 2 minus 6 root 27 because I combined the 2 threes and the 27 because you can combine like terms. And then on my next step, I got 2 root 2 minus 6. And then, like, you know how you did for the 13, you
Yeah,
24.
you multiply 6 and 3, you would get 18. You'd get the same thing.
Yeah, so that's okay that I did it that way?
Absolutely. I
Yeah.
love the fact that you saw that those two things were in common. I'm proud of you.
Appreciate it, Miss Sparks.
Yeah, to me, some of the cool things about math is we might approach them all a little differently, but as long as you stay within those rules, it's great. So you got the same answer. Really proud of you.
Thank you.
That's awesome. Awesome. All right, Matthew, did you come up with another question?
No, I'm just working let's see. Number 19 out again.
Okay. Oh, yeah. Completing the square. Love those.
Can we do number can we do number 19?
Absolutely. Thought you'd never ask.
Yeah, well, I was
Try to
trying
make me happy, don't you always, Braden?
always, Miss Sparks.
X squared minus 2x minus 26 equals -2. So what I want to do is create that space on the left side to complete the square. So I'm going to add 26 to both sides. And I'm going to keep that space right there because this is where I want to half it, square it, add it. And then over here on this side, I've got my 24. All right, so this is where I'm going to half it, square it, add it, and make up my own C term to create that perfect square trinomial. So I take half of -2, which is -1, and then I take -1 and square it, which is 1, and then I'm going to add that to both sides because I can't change the value.
You do that for the x value, correct?
Yes.
The
Yes.
2x? Okay.
The -2. Yes, sir. Great question. This value right here. So then now this is a perfect square trinomial. And a perfect square trinomial is where remember what we said was half of -2 was -1. So that's what that looks like. That's a perfect square trinomial. It breaks down into a binomial squared. So if I actually were to take x minus 1 and FOIL it out, x minus 1 times x minus 1, because that's really another way to write x minus 1 squared. and I were to FOIL it out, it would become this perfect square trinomial. That's why it's called completing the square.
Okay.
Okay, so now I have x minus 1 squared equals 25. Now, to solve this, which is the next step, we completed the square, and now we're going to solve it. We're going to take the square root of both sides, which that's going to be x minus 1 equals plus or minus 5. And so now I'm going to add 1 to a positive 5, which would give me 6.
Wait, where'd you get the
And then I'm
negative
going
1
to
from?
add 1. I'm sorry?
Where'd you get the negative 1 from?
The negative 1?
Yeah, like, oh, you just did the square root. I see what you did.
Yeah.
Okay. Okay.
Yeah, I took the square root of that, which took it out. So I'm going to add 1 to both sides, and then I add 1 to the positive 5, I got a 6. And I add 1 to negative 5, and I get a negative 4. So my two answers are 6 and negative 4.
Awesome. I'm going to go ahead and try number 17 and 18 really quick, and if I have questions, I'll ask for you.
Okay. Is Matthew still with us?
Yep.
Okay. Y'all let me know if you have questions or you want me to work one out.
Alrighty.
Hey, Sparks,
Yes.
could you do number 12?
Absolutely. Who else is with us? Is that Garrett?
Yeah.
Hey, I can absolutely do it. Oh, love number 12. We're going to rationalize the denominator by multiplying the top and the bottom by the conjugate of the denominator. And what that means is whatever that opposite sign is inside there. So the conjugate is 3 minus 5i. And whatever I do to the bottom, I have to do to the top. So that's why I'm doing it this way to rationalize it. I'm multiplying. So basically that means I'm foiling the top. Actually, I'm foiling the bottom too, but it forces me for that middle term to cancel out because it's kind of like the difference of two squares. But if I foil the top, I've got negative 6. Foil first, outside, inside, last. Negative 6 times negative 3. That's going to be negative 18. Outside is negative 6 times negative 5i. That's going to be a positive 30i. Inside is negative 2i times 3. That's going to be negative 6i. And then last is negative 2i times negative 5i. That's going to be a positive 10i squared all over. And then if I FOIL this, I've got 9 minus 15i plus 15i minus 25i squared. Okay, that these two terms cancel out, and that's the whole reason that you multiply by the conjugate. That's what happens on the denominator. In the numerator, we've got negative 18, and we've got plus 30i and minus 6i. So that's going to give us a plus 24i. And now I squared is really a negative 1, isn't it?
Yeah.
So I'm doing 10 times negative 1. So that's going to be minus 10. All over 9. And then if I take a negative 25 and multiply it by a negative 1, that's going to be plus 25. Running out of room. Oops. All right, so now at the top, I'm going to take my negative 18 and my negative 10. That's going to give me a negative 28 plus 24i all over 34. And I notice they're all even and divisible by 2. So if I divide negative 28 by 2, I get a negative 14. If I divide 24i by 2, I get a positive 12i. And if I divide 34 by 2, I get a 17.
Okay, that makes more sense.
All right, great. So, great question. Y'all are asking really, really good questions. So proud of you guys. All right. Any questions on somewhere else?
Could you do number 28?
Number 28. I can. And I want to talk about number 28. I already know Miss Wynn is going to change hers that's like this on the final, and it's going to be written on the board. I'm still kind of praying about what I'm going to do. I may do something really similar. So it would be there's already 2 that I have to hand grade anyway, so I may hand grade that one. But I just want to talk about the meaning behind it. Great question, though. I'm so glad that you asked. Find all rational zeros. And what that means is obviously we've done all these fancy things to figure out how we can even find imaginary zeros. And so what it's asking here, find the rational zeros. Those are going to be the ones that you actually can see more readily on the coordinate plane because it's going to cross at a definite point. Okay. And 1 is given. So this means if I were to plug this right here into my calculator, that equation, x to the 4th minus x to the 3rd minus 7x squared plus x plus 6, if I were to plug that whole thing into my calculator, the zeros of this would be everywhere that polynomial crossed the x-axis. So if there is a worst case scenario and you want to figure this one out, you would graph it and see where it crosses the x-axis. Does that make sense to you guys?
Yes.
Okay, cool. Now, by the long way to do it, which to me is more fun, you've got 3. So you're going to use synthetic division, and you're going to take the coefficients. The coefficient on here is 1. The coefficient on the x cubed term is -1. The coefficient on the x squared term is -7. The coefficient on the x term is 1. And obviously the constant is 6. We didn't need any fillers. That's another thing that you want to check for. 1, 2, 3, 4, 5. We got all 5 terms represented there. And so now we'll begin synthetic division. You drop down, multiply, add. Drop, and then multiply, add. Multiply, add, multiply. So now I have really, this technically is x cubed minus or plus 2x squared minus 7x minus 2. All right. So you would have to go back to your rational zeros, like your possibilities of rational zeros. Okay. That was that good old P over Q. So you would take the factors of 6 for the P, That's going to be 6 and 1 and 3 and 2. And then the factors of 1, oh, yay, are 1. And then you think of all the possibilities. So like 6 over 1, 1 over 1, 3 plus or minus. And these are all plus or minus. 3 over 1 and 2 over 1. Well, these are all plus or minus. Okay. So I'm going to start with, and this is where the multiple choice is a blessing. But if not, I always start with 1. And you can see that some of the bigger numbers aren't one of the possibilities for these. But I'm going to start with 1. Okay. And I'm going to plug in. I'm going to erase this. I'm going to plug in one of my possible zeros and do synthetic division again. And I'm going to start with 1. Okay. And I'm doing synthetic division on my answer for my previous synthetic division problem. So I'm going to drop 1 down, multiply, add. 3 times 1 is 3. And then combine a -1 and 3. So now I have x squared plus 3x plus 2. And that's easily factorable because what are the factors of 2 that multiply to give me 2 that when added give me a 3? Very easy factoring problem. X plus 2 and x plus 1 because 2 times 1 is 2. 2 plus 1 is 3. So that tells me my factors are -2, -1, +1, and +3. So here's my answer. Did that clarify some things for everybody on how to do those?
Yes, ma'am.
Great. Who else is with me? Thank you. Great question. Who else is with me? Did that help? Garrett, Braden, Matthew?
Yeah, sort of. Kind of.
Okay.
Yep.
Is there going to be anything like that on the exam?
That's what I was talking about. On number 20, yes, there will be something like that on the exam.
Okay. Just one or multiple?
Just one.
Okay.
Just one. And that was the one at the very beginning where I was talking about if you graph it, do you know how to graph polynomials on your calculator?
On my calculator, yes, ma'am.
Okay. Wherever it crosses the x-axis is the rational zero.
Oh, yeah.
Remember that?
Yes, ma'am. I remember that now.
So if you want to confirm your answers, that's always a beautiful thing.
Yeah, so if I just really wanted to know what the answers were, I just enter it into my calculator. That's the easiest way, right?
Well, yes and no. Sometimes the calculator, when you pull it up on there, it's a very difficult thing to see exactly where it's crossing.
Well,
If you had kind of an
arrows.
idea going in what it was going to be, you could look and say, yes, that looks right. So it's kind of like one of those things. I guess if you saw that it was for sure going through 3 and you could go from there because obviously one of your zeros is definitely 3 because 1 0 has been given. And the problem looks exactly like this. The numbers will be different, but yes.
Awesome.
Good questions, guys.
How many questions are on the, or like how many problems are on the exam?
Hold on just one second. Let me confirm for you and give you the exact one.
Alrighty.
And Miss Wynn's is a little different than mine. And I'm not positive how many are on hers, but I think it's, I can't remember. So this is only for Miss Sparks. think this is mine. 40.
Okay. That's not that bad.
No. I tried to make it where you had roughly a little over 2 minutes for each one.
Okay. Can we do number 26 and 27?
Absolutely. Number 26, we're supposed to name each polynomial by degree and the number of terms in it.
Oh wait, no, I
First thing
know that one. That's
okay, not that one?
No,
Okay.
I understand that. Never mind.
Okay.
Wait, which one was it? It was number 21. That was the
Number
one.
21.
Yeah.
21. I got you. So what you're going to do on here is I would deal with the exponent first, which means I've got to multiply everything inside by this -1. So then that's going to give me 2, -1, x, -1, y, -2. And then I've got this x.
No, that's fine.
2, -1. I'm going to write it up here since I'm running out of space. So now 2, -1 is going to be, it'll be kind of all by itself. I'm just going to get it simplified first and then deal with the negative exponent. And then I've got -1, and this is an understood 1, and this is an understood 1. So -1 and 1, that's 0. And then that gives me x to the 1. And then -2 plus 3, that gives me 1, plus 3 more is y to the 4th. Now this negative exponent tells me then that's going to go to the denominator. And everything else stays in the numerator because a negative exponent makes a fraction. So that's just going to go down to the bottom. I forgot my 4 there. So that's that answer. So it's x to the 4th divided by 2 because a negative exponent takes it to the denominator.
How do you get the -4 for the y?
That's not a negative. It probably just looks bad because my writing is bad. I'm sorry.
I mean a 4, sorry.
A 4?
Yeah,
okay. I've got a -2 plus 3. That's 1. Plus 3 more is 4.
Okay.
Good questions. Everybody remember that negative exponents take it to the denominator? Good review. So that's going to be what happens in number 22 as well, because when you raise that 2 to a -2, that's going to mean there's going to be a 4 in the denominator and the x in the denominator. Right. That just basically sends everything to the denominator, except you have to square that 2. Any other specific questions?
Could you work number 31?
31?
Yeah.
Absolutely. Yes. Okay. This one is a composite function, and how we saw them in our textbook. They were written like this.
Oh, geez.
Okay. So when you see that funky little circle thing, it is the same thing as this. It's called a composite. Okay. So the very first thing that you want to do then is plug in -3 into the G. So we'll do -3. So anywhere there's an X, we'll plug in this -3 minus 2. So that's going to be -5. And now we take the answer to G, which is -5, and we're going to plug that in to X. So everywhere there's an X, we'll plug in -5. So the opposite of -5 is 5 plus 3. So that's 8. Yeah, some of the signs can make that a little confusing. Does that make better sense? After I wrote it like that, I bet you recognized it for sure.
Yeah, I did.
So, and I think it's written like that on the exam tomorrow.
Thanks for the help.
Oh, no problem. Just want to give you guys a heads up about that. Let me just double check. Yes, it is definitely written like that on the exam tomorrow. And let's just do this as an extra example. For this one, if you don't mind, you guys, because this is a little more like the one that's on the exam. So let's do that just so you have some practice. If that was not a number, and let's just say this right here was an X, okay? So then what you're looking at is you would have something like this. So I would have G of X, which really is this, okay? And they're asking me to plug that in to this. So anywhere there's an X, I would be plugging in X minus 2. So now I'm going to distribute that negative. So my final answer would be this. Okay? So you can have these composites where they're not asking you to do a number, they're actually asking you to do a letter or a variable. So that's an extra example for you to help out for the exam tomorrow. You might want to write it down.
Makes a lot more sense. Thanks, Ms. Sparks.
Okay, no problem. No problem. I want to make sure everybody had a chance. Did everybody get that written down? Everybody good with swapping back and forth in between the different forms, the radical and the exponential? Feeling pretty confident about those?
Those are all the questions I had.
Okay, good. Because I know you had some extra also on a separate sheet of paper, Garrett, that Miss Wynn gave y'all. So if you need help with those, let me know too.
Okay.
But great. Glad to hear it. Y'all are doing great. Alex, do you have anything else, honey?
Can you do number 38, please?
38. Yes. Yes. 18 equals 8 plus square root of x over 8. So I'm going to subtract 8 from both sides. Whoops, that doesn't look like an 8. Oh, my. That gives me 10 equals root x over 8. So now I'm going to square both sides. So that gives me 100 equals x over 8. And now I'm going to multiply both sides by 8. So that gives me 800 equals x.
Hey, Miss Sparks, I think I'm good. I'm gonna get off of lab now.
Okay, honey.
Thank you so much.
You know what? If you're working through this later and you come up with any questions, email me.
I will. Thank you.
Okay? No problem. All right. And I can just work through them too if you guys want me to. If there's any other questions.
Miss Sparks,
Yes.
could you do let's see, 43 through 45?
I absolutely can. On the 44 and 45, I don't have a calculator that I don't know. Let me turn my phone sideways and see how I do it, how I can do it. But on number 43, great question. What I want to think of is kind of like what I was relating to before. What makes something go to the denominator? What type of exponent?
Can you
Remember
say that again?
before?
I'm sorry.
What type of exponent makes something go to the denominator? Remember when I was working this one let's see, where was it? Way back. Feel like, where was it? Oh, here. Remember on this type of exponent takes it to the denominator. That's what turns something into a fraction, is the negative. Okay. So when you look at something and you see that it's a fraction, you should be thinking in your mind, oh, that's a negative exponent.
Okay.
So remember, a log is an exponent. So it's asking, what do I have to raise 3 to get 1 over 27? And you should be thinking, oh my gosh, that's a fraction. So that's definitely going to be a negative exponent. Does that make sense? And so now what you want to think of is, what is 3 raised to what will give me 27? And technically on this one, there's only one negative answer. So it's -3. So that's how you work it. That's how you work those backwards. A log is an exponent. So 3 raised to some power equals 1 over 27. And you automatically know when it's a fraction that it's going to be a. Whoops.
Okay.
Does that help?
That does, yes.
Okay. And then, okay, I'm sorry, 44. And what you would want to do on these is you would plug this straight into your calculator. Just like that. There is a log base button on your calculator, but if you want to do it this way, you can too. Does that make sense? I'm trying to get my phone calculator to turn sideways. I still don't have my calculator yet. Okay. So what you would do is you would hit log 6.9 on your calculator divided by log 2, and then you should get that. Does that make sense? Did I lose you? And this one was kind of cool because if you actually looked at it, 4 raised to what would give you 2. And you know that 2 is the square root of 4, so that would be 1/2, which that's the answer, but you could still plug it in your calculator. Are you okay with getting those in your calculator?
Yes, I am.
Okay. How about the parent functions? I'm sorry, go ahead.
So did you do 38 with Alex?
I did, but I can do it again. It
Okay.
doesn't matter. I'm happy to do it again if you need me to.
Okay.
It's not
That's
a big
the last
deal.
one I have.
Okay, not a big deal. I can do it as many times as y'all need me to. I was planning on doing math lab till 3 o'clock. Y'all have mastered this stuff. I'm so proud of you guys. All right, so we're going to subtract 8 from both sides because you always work in PEMDAS in reverse. So you want to start with that addition and subtraction and see if there's any place that you can subtract that out. Okay. So now we've got, or if there's anything to add or subtract out, maybe that's a better way to say it. And now we've got 10 equals the square root of x over 8. And so to get rid of that radical, you're going to square both sides. So that gives you 100 equals x over 8. And now to get x all by itself, you're going to multiply both sides by 8. Because to undo division, you multiply. So you got that.
Okay.
All right.
So what problems are you gonna take off from the study guide that are on the final, or that you're gonna take off on the final?
Let's see. I'm trying to, a lot of them, like where I asked multiples, like, okay, there's, what did I ask? I asked 4 of the graphing ones like this, the absolute value and the parabola, there's 3.
Okay.
The factoring, I think I left every single one of the factoring ones in there.
All right.
Like, so there, I think there's 5 factoring ones. I think there's 5 factoring ones on the final exam.
Okay.
So just because one of the other reasons I did that, let me see, 1, 2, 3. Oh, no, I didn't. I took one off. The kind that I took off is it looks like the kind I took off was the kind like number 6, where you didn't have to find a common factor.
Oh, okay.
Everything else kind of is the same.
All right.
Okay. That's the only one that I took off. And the reason for that, as soon as we get back in January, we're going to be dealing with factoring again. As a matter of fact, day 1, when y'all get back, we're going to do a factoring review. I should have left it on there, actually. But unfortunately, it just doesn't go away. But so there's 4 of those. And then I think, let's see, on this eye problems, those stay pretty much the same. There's a 10, like it's 10, 11, and 12 on here. There's one of each of those. I'm trying to go through just everything with you. Okay, on the radical ones, those kind of stay the same. There's 3 of those, just like there was on the review. Wait a minute. Let's see. Yeah. Well, like 13, 14, 15, there's only 2 like those. And then there's one like 16. There's 2 where you take the square roots, and there's 1 where you complete the square. And just remember, kind of a note to you, when you're completing the square, it doesn't always have to be a pretty answer. There can still be a
Okay.
radical in the answer, okay?
Yeah. Okay.
That's just a little note to you about that. One where you have used the quadratic formula, just like on the review. There's only one like 21 and 22. Only one of those. There's only one like 23 and 24. There's only one of those. There's one where you have to evaluate the function at a given value. And there's one like number 26 and 27. There's only one of those.
Okay.
Number 28, there'll be one of those, and I'm not sure what it's going to look like yet, but there'll be one of those. And the function ones where you perform the indicated operation, I think there's 3 on the review and there's 2 on the final.
All right.
There's one of each where you have to change it from radical form to from the rational exponent form to the radical, just like 32 and 33, one of each of those. There's one of each of those on the exam. On the simplify, there's 2 of those, just like there was on the exam. The inverse function, there's 2 of those. There's one like 38, one like 39, one like 40, but we're already at 33 on the exam. So there's one like 41, one like 42. One like 43. And there's 2. Like, were you okay after I went through 44 and 45? Were you okay with those? Because
Yes,
there's
I
2
was.
of those. Okay.
Okay.
There's two of those. And number 46 and 47. There's 2 like that. So know your parent functions.
All right. Cool.
And then that would be 40 questions.
Yeah.
So does that help a little bit to kind of know what to expect?
Yes, it does.
Okay, cool.
All right. Thank you.
No problem. Email me if you have any other questions, okay?
Okay, I will.
All right, you take care.
You too. Bye.
Bye-bye.